Hi everyone, my name is Kent C. Dodds and I'm super excited to be joined by my friend Brian Vaughn. Say hi, Brian.
Hi, everybody.
So Brian and I actually go pretty far back in the AngularJS days. I was working on Angular formally. Brian wanted to help, actually, was it? I don't think it was you. There was somebody who brought a bunch of us together who were doing forms libraries.
Yeah,
Um, and yeah, you were working on one, I was working on another, and we kind of had this little effort to make the forms JS. I think that you put the most work into it, and then it just kind of fizzled off. So sorry about that. But,
happens.
yeah, I think it was a hard problem. But yeah, so that was years ago, and then we both found our way. I think you went through Google and then over to Facebook, and I found my way somehow into React, and now here we are. So, do you want to give a little intro to yourself? Like, what do you work on, and what are you doing, and then we can chat about React DevTools and stuff.
Yeah, sure thing. So, like Kent said, I'm Brian. I'm on the React core team at Facebook. I've been there for almost 4 years. The core team is pretty small, so we all work on a variety of things, but we also each kind of have our specializations. And I guess I would be the person on the team that specializes in developer tooling and sort of our profiling APIs and the various things that sort of go along with performance profiling.
Nice. And you've been working on that for like 2 years now, right? Or maybe longer.
Yeah, probably the I guess DevTools rewrite for our extension and our npm package, and then the profiler API are both about 2.5 years old. So it's been my focus for a couple of years now.
Yeah. Wow, man. And I remember watching that rewrite, and getting I think I was early adopter. Like, I built it locally so that I could use it. It was a really great upgrade. So thank you. And it's just been improving ever since. So it's been awesome. And actually, one other thing about the dev tools in the code base, there's one thing that I teach about in Epic React, where for context, like how you share context effectively, and like helper methods and stuff. And yeah, just a pattern for making it easier to do like code splitting and various other things. And I observed that pattern in the DevTools code base. That's actually, Dan convinced me of this idea of something that they do at Facebook. And we don't have to like dive into it deeply or anything, but that was the DevTools is where he showed me this pattern. So
Oh, cool.
I've dived into the code there, and it's pretty great. So thank you.
Glad to hear it.
So cool. Well, so the DevTools. Oh, one other thing interesting about the DevTools is I think that the DevTools are probably the best metric for how many users there are of a particular framework. Uh,
Yeah.
Maybe not a perfect metric, but the best that we have. And I looked just yesterday. There are over 2 million users of the DevTools.
Yeah, that sounds about right. I think we've got probably in the ballpark of 100, 150,000 NPM users. So these are folks that use the standalone DevTools for React Native primarily.
Mm.
And then we've got Edge and Firefox DevTools, which are both still growing community. But then Chrome just gives us the kind of course 2 million plus. So we're somewhere over 2 million weekly active for Chrome.
Yeah, yeah, that's wild. Like, that is so
Pretty
many.
crazy. Yeah, pretty crazy.
Yeah, that's amazing. I don't know how many people who build developer tooling can say that they ship developer tooling to millions of people. Like maybe VS Code and those kinds of things, but like that's yeah, that's a lot of people.
Yeah, it's pretty intimidating, or it was. I'm numb to it now, but I remember publishing the first few major releases, and it's scary because I mean, Chrome does give you the ability to roll out gradually, um, so you can sort of detect a bug and roll back, but that assumes that you're tracking metrics, and we're not. Like
Mm,
we're very intentional about not tracking any user metrics, any usage other than Chrome's own like daily active extension things, which we're totally decoupled from.
sure.
So if something breaks, we find out through GitHub issues. So whenever I publish an update, it's 100% out within a couple hours whenever Chrome flips the switch.
Yeah, yeah. How do you maintain your confidence? Like, is there a test suite for the dev tools and that sort of thing?
there's pretty good end-to-end integration tests. It's a little it's creatively wired up, I guess I would say. Basically, the way DevTools works, it's a React application itself, and it runs in a separate memory space in the browser as an extension. And so you might be using React 15 in your website, and DevTools is built on whatever the latest master React 16 version is, soon to be 17, I guess. And they talk to each other through post message primarily. So for our test, to simulate that, I load two versions of React into the test script. One, depending on the test, we run tests against version 15 and version 16. We'll load React DOM of that version, and then we'll do some just magic to reset modules and stuff, and then we'll load React Test Renderer to run the DevTools UI. And then they use the same serialization mechanism to talk to each other. So we can basically, our tests, if you ever want to poke around at them, I think they're pretty cool. They, you render things into the React DOM version of React, and you can dispatch events and do state updates and anything like you normally would in a test. And then that React DOM is talking through the bridge to your DevTools. And then you can assert things about the DevTools store, which is the thing that holds sort of the state of the tree. And I wrote a custom jest snapshot serializer, whatever they call it. So whenever DevTools breaks, you get a nice pretty printed diff that shows like the before and after. And it's made testing, test writing and test maintenance super nice, super easy. So that was a fun like challenge to figure out how to get everything wired up, but it's pretty valuable. Anytime we find a bug, certain types of bugs are obviously harder to capture if they're, user interaction type bugs, but those have been really far and really few, I should say. Most of the integration tests give us pretty good coverage, and then we just do some basic smoke testing on a couple of sites like the React.js docs and Facebook, obviously, just to make sure it's sort of sanity check stuff. But it's a surprisingly minimal amount of testing considering I might smoke test a release for 5 minutes before I publish it. We do another thing that helps a little bit with confidence too, though, which is I have an internal group at Facebook that folks can join. And then we have an experiment running for everyone who's a member of this group that uses Chef to push out sort of pre-built installations of DevTools. So if I'm trying a major new feature like the suspense toggle or new profiler UIs or whatever, I roll it out to a group of, it's probably a couple hundred Facebook engineers. I don't even know the size of the group at this point, and let them use it for a week. And if something breaks, they tell me, and otherwise I assume that it's pretty good. So
yeah, that sounds pretty solid. Like it's not like you're gonna break a checkout button or something. So but that sounds like a pretty solid way to feel pretty good about releasing stuff. So good. And I've never noticed like any enormous breaking issues. So
we've had very few. We've been fortunate. There's been maybe one in the past year, and I was notified pretty quickly and rolled out an update pretty quickly. So overall, it's knock on wood, I guess.
Yeah, yeah, it's cool. So with the DevTools, there are the two tabs. You've got the one for the components, which is just like really awesome, the stuff that you can do in there. And if there's anything you want to call out specifically in there, then we can totally chat about that stuff. I do give people in Epic React, I give them kind of an exploration of here's the DevTools, here's what you want to know about them. I'd love to talk more on the profiler side of the DevTools, and not just the React DevTools, but also like the performance profiler of the Chrome DevTools and what you know about that, what you've learned in building the profiler and stuff. So like, I guess a good lead-in question to get us talking about this is, why is it like if the Chrome DevTools and Firefox DevTools, they already have their performance profilers, why is it necessary to have a profiler for React DevTools?
Yeah, I see there's a bunch of answers to this. I guess one of the answers that's maybe on the surface is that the React application tree is separate from, it's often closely related to the DOM tree, but it's not always the same. So especially when you think of things like portals, then you can have sort of your React application tree with all your components, and then a component that's far down in the tree might actually render to a totally different root in the DOM. So they're decoupled for one thing. And then also the properties and attributes are different as well. So, you might pass in a property like class name to your React component, and that might get attached to the DOM as one of in the class list. And so sometimes they're an obvious mapping, but sometimes they're totally different. And so just like the browsers have their own elements panel, which gives you sort of a nice style inspector that does some fancy formatting and checking for CSS properties and things like that, the React DevTools components tree gives you nicely formatted sort of interactive breakdowns of your props, your state, and your hooks, and context, obviously, if you're using that as well. So just having them sort of formatted there in a way that is sort of smarter than they would otherwise be if you just viewed them as properties in the DOM helps. Another, I think, interesting answer as we move forward with a bunch of new APIs that the React team has been exploring now for pretty much most of the time I've been on the team, which is sort of concurrent mode and all of the bucket of things that go with it, like suspense and other APIs we're working on, is that the built-in browser profiling tools kind of leave, there's a gap between what React can do and the sort of interactions the browsers typically meant to profile. So an example of this that I think is an example of the browsers adapting in a way that's really cool is when they added the async call stack to the debugger. So it used to be that if you set a timeout or you had an event handler or something come back and you hit a breakpoint, you could just see, oh, well, this is set timeout. I don't know what it's in reference to. And the browsers added this sort of support to backtrace to the stack many frames ago when the native API was called, so you can sort of step backwards and see, oh, well, this was the timeout of the event listener added here. There's a similar gap right now that hasn't been filled by the browsers, and I think they'll do more in the future. But for libraries like React, so React has a couple of things that make it challenging to profile using the built-in profiling tools. One of them is the concurrent mode APIs that I mentioned. So React, I know people have probably heard explanations of concurrent mode in a bunch of places, but essentially, so JavaScript in the browser is single-threaded, which simplifies a lot of things when you're programming, but it can also cause a lot of problems. So like if I have a script that parses a huge file and does something with it, the web page can feel completely locked up during the time when my script is running. Other scripts can't run, event handlers can't run. So what React does with the new concurrent mode APIs, what React will do to help with this, one thing it'll do is it'll yield every couple of milliseconds to the browser, and it'll be like, hey, do you have anything to do? If you do, go for it. If you don't, hand back to me and I'll work some more. So this keeps the web page feeling interactive and responsive. Another thing that it does is it has this baked in concept of priorities. They're kind of like threads. They're not truly like threads, but it's a way that React can sort of prioritize different categories of work. So like, let's say that I'm rendering a page, like a tabbed container, and I want to render the tab that's currently selected at the highest priority. But let's say I start rendering the tree and then I reach a component that uses the suspense API to say, I need some data before I can do anything else. So it throws a promise. Well, I could wait on that IO to like send a network request and come back and then resume my rendering, but that's potentially just wasting some amount of CPU cycles where I'm doing nothing. So instead, React concurrent mode has this built-in sense of other scheduled work that's maybe at a lower priority. So maybe I've told it to pre-render the other tabs so that they're going to be faster to display when the user clicks them. So while I'm waiting on IO for the higher priority work, I can start working on this idle priority stuff in the background and then yield as soon as I'm ready to come back to the higher priority stuff. Similarly, if I'm rendering something like, let's say you click a few things, maybe I start rendering something and it's not done. I'm not blocking on IO though, but then the user clicks something and it's a higher priority interaction. Then React can do a couple of things. It can throw away what it was working on and take the higher priority thing, or it could just set what it was working on aside and process the higher priority update and then go back. So there's a lot of interesting sort of cooperative scheduling stuff that it does that if you were using Chrome's built-in performance tab to debug, it would just look like it's all React. It's just all JavaScript. And you don't have insight into this because the performance profile, unlike the debugger, when you hit a breakpoint, it shows you sort of all the variables in scope and you can inspect things, interact in the console. The performance panel doesn't do that. It just shows you sort of call stacks how long each function took to execute and at what time it executed. And then you can see things like, oh, there was a click or a keyboard event or a network event, but that's it. You don't have the state of your application at that time, so it's hard to reason about. So we've been working on a lot of tooling over the past couple of years, sort of while we've been rolling out and testing these new APIs inside of Facebook. We sort of noticed the gaps where product developers will come to us and say, this part of the page is taking a long time to render, I don't know why. And we'll sit down and look at it with them. And then we'll say, well, here is why, but I only know this because I know the code really well that's in this part of React. So there's no way you could have known this. And then we sort of work backwards. So like, what kind of tool could we have built to make that easier? So one of the first things we built, it's been a while now, but it was this profiler you mentioned. So the profiler shows you sort of snapshots where React committed work to the DOM, for instance. So React does work in two phases. It has a render phase, which is when it calls, render on your class components, or when it runs your function components and you do your work and return the child components and so forth. That work is what the new concurrent mode will do sort of in that yieldy time slice way. And the reason is that work is generally the longest running work, takes the longest to process. And also, if an error is thrown or an interruption comes in that's higher priority, that work can be set aside or thrown away entirely with very little cost. And then when while React is doing this rendering, it's building up a small set of instructions it'll need to apply to the DOM to sort of change it based on your rendering. And when it's done, we enter in what's called the commit phase, which is when we actually mutate the DOM. And so it's important that we don't mutate the DOM during render, because if we have an error, now the DOM is going to be in a broken half mutated state. So there's these two phases. So the commit phase is when we actually change the DOM or the native view. And the profiler shows you each of these commit phases. So it shows when it was committed, which components actually resulted in changes that were committed. And then it lets you drill down more into the state, which is something that Chrome, that the built-in browser profiles don't do. So it'll say, oh, this component rendered and committed because this prop changed, or because its state or its hooks changed. So it gives you a little bit more insight into that. And it lets you know things like a commit took a long time because this part of the tree took a long time to render. And then you can drill in and say, well, why? Was something slow? Should it have been memoized? Did it even need to render at all? Like maybe could use the should component update type APIs to prevent the re-renders. So it's a sort of additional set of tools that go along with the browser profile for diagnosing that sort of stuff. I've been talking for what feels like a half an hour, so I'm going to yield and let you jump in. And
that was awesome. I didn't expect to get a conversation about concurrent mode and the impact, but that makes total sense that if React is like, do some work, yield to the browser, do some more work, I can imagine that the flame graph of the dev tools, like the Chrome dev tools, would just be like just this choppy thing of like React does stuff. But the React dev tools can kind of give a more cohesive, like, here's the thing that React was working on in between all of those things.
Yeah, and the flame graph is another thing that it used to be with React 15. Our rendering was recursive. And we also used user timing APIs to sort of mark like a flame graph above in the user timing section of the profiler, such that if you were profiling and you saw like a really wide function call in the call stack, you could sort of reason about where you were in the React tree based on the call stack above you. But with React 16 plus, in order to support these sort of concurrent yieldy APIs, we don't use recursion anymore. We iteratively walk through the tree. And so we're only ever rendering sort of one component deep at a time. And when we're done with it, then we reset what the current fiber is that we're working on, and we work on another thing. So what this means for the sort of flame graph in your profiler is that it's very short. It's a couple of React functions or React DOM functions, and then it's one of your functions, and then it steps back up, and then it's one of your functions. So when you're using it, if you spend a lot of time and zoom in, you can find your component calls, and you can see sort of like, oh, this one took this amount of time, but it's very, you have to spend a lot of time to like drill in far enough to see it. And then once you drill in, like you don't have that context. So the profiler was sort of optimized to give you all of that at a glance. We use sort of both texture, like the solid color or the diagonal stripes, to sort of give you at a glance, oh, this didn't render at all versus this did render. And then we also sort of obscure the things that so as a product developer, if whether or not React DOM is efficient is something you can't control. I mean, you could contribute to the GitHub repo, but it's when you're optimizing your app, that's kind of like a couple of steps removed. So what the profiler does is it focuses only on your components. So the time it reports, for example, are all the time spent in your components and your functions, because those are the things you can immediately affect. And so like all of those views were written up to emphasize that and sort of de-emphasize what in the native browser's performance tab, the majority of the call stack is all React DOM code, which you don't know, you're not familiar with it, and you can't change it.
Right. Yeah, sure. And so one thing like regarding performance that I talk a lot about in Epic React is that the secret to improved performance is running less code. And so like the getting a focus on like, here are the things that your code is doing helps us avoid the noise of what the Chrome developer tools gives us. Well, but another thing that I wanted to kind of talk about a little bit is looking at the actual numbers, like the amount of time especially in the React dev tools, and thinking, oh, okay, well, this is taking 20 milliseconds. That's greater than 16, so this is slow. And that's important, except one thing that I think I want to just talk about a little bit is the difference between production mode and development mode, and how like my mind is kind of in a jumble, but like you can't really, during development mode, you can't really look at those times as what the user's going to experience. And then if you do want to use production mode, which is what the user will experience, then you can't use the dev tools without flipping on a little switch. So can you talk about like why that's important? Like what's the difference between development, production, and profiling? And what, like, why should people, or when should those numbers of milliseconds actually count for people?
Yeah, so there's three builds of React DOM. There in React, we have a development build, a production build, and a profiling build. So the development build is the thing that you're generally running locally when you're iterating in your code. And it does a lot of additional things for you that are trying to sort of point out problems that would eventually be pushed to production if you didn't fix them. So what this means is we have a lot of code in React itself that we have sort of if dev mode conditional gates wrapped around. And then we do things that we strip that code out of production. So the things that we do, we'll do a lot of extra validations of things, the params that you're passing into functions. We will, in some context, call render or call lifecycle method twice in a row to sort of tease out side effects. A lot of additional things we do, we'll check return types, for instance, from a render function, and if it's undefined, we'll warn, because maybe that means you forgot a return statement, or maybe it means you're returning something you thought was a component, but your import was wrong, so it's undefined. So there's a lot of things that we check for that have, over the years, bugs have been reported to us, and we've said, oh, this is a bug we could have warned about. And so dev mode is very heavy. It's fine if you're running like a new fancy developer laptop. It's plenty fast for you. But it's definitely not something you would want to deploy to your end users, because they're not going to get any value over it. It's strictly going to waste their battery. So that's dev mode. You can do some profiling in dev mode if you want to, for example, just check to see if something is re-rendering when it shouldn't. That's going to be the same. But you shouldn't pay much attention to the milliseconds values, because dev mode is definitely, I don't know that there's an exact, it would depend on the type of application. We can't assign like it's 2x slower.
Right, yeah.
But it is probably on that order of magnitude. It's much slower.
Yeah. I think those milliseconds can be useful if you think about them relative to each other. Yeah. So like within here, this is like relatively twice as long as this. And
yeah, I want to circle back to that relative thing, because that's super relevant. The production bundle is sort of the optimize. We strip out all of those dev-only checks. We minimize the code. We run it through Google's Clojure compiler to do a bunch of additional inlining and stuff to make it as small and as fast as we can. So this assumes you fixed all those bugs, potential bugs we've warned you about in production mode, and now we're just wanting to make it run as fast as possible for the end users. And then this profiling bundle is sorry, let me ignore this. The profiling bundle is a relatively new addition that is, I mean, it's probably 2 years old at this point, but it's much newer than
it's new to me too, but yeah, it's been around for a while.
Which is the production bundle with everything stripped out, and then a tiny bit of additional stuff added on top, which are the APIs that we need to support the profiler. So the profiler API is this thing you can wrap around parts of your application tree, and React will tell you each time it commits, we'll call a callback you give it, and we'll say, here's some numbers about how long this sort of subsection of your app took to render. And you can put these all throughout your app. So you can put one at the top and some inside, and you can like record these to your server if you want. So in the production bundle, this profiler API does nothing. It just passes through like the fragment API would, it passes through its children. But in the dev and profiling bundles, it collects time and reports it. So that's the difference. And it also, circling back to the DevTools, you can also use the DevTools profiler for the dev and profiling bundles to do all the stuff we talked about earlier. But in production, the profiler is disabled. You mentioned something about milliseconds and how it's all relevant. And I wanted to call that out because it definitely is relevant, relative. In a couple of ways, people that are developers are probably running pretty fast hardware. And so it's important, I think, that you don't look at the profiler and think, oh, well, this is faster than 16 milliseconds, so I'm good. Because you are probably good, but maybe someone that's running on a mobile phone or a slower laptop isn't good. So that's why the React Profiler UI, we don't show, so people have in the past asked us to do sort of indications of like good and bad or safe and unsafe.
Yeah. And
we can't because we don't know enough to make that call. So instead, all of the sort of colorings and the widths and everything are on our gradient that's all relative to the rest of your app. So we can say the orange part of the tree here, that's the slowest part, and the blue part is the fastest part, but maybe they're both fast enough, or maybe even the fastest part is too slow. We rely on you to make that judgment with your additional context that you have. But there is something that we're working on inside of Facebook that's pretty cool. I think it's probably many months. This is probably a 2021 thing. I should just put it that way and leave it vague. But we've worked a little bit in the past with, so the browser has additional metrics that aren't exposed to JavaScript yet. But we have some builds internally that we've played with that exposes one of these metrics, which is the instruction count. So when JavaScript does things, the browser, those ultimately boil down to instructions, and the browser can track the number of these instructions between periods of time. And the cost of these instructions differ a little bit depending on what you're doing, but it is possible for you to assign like a rough weight to sort of an average instruction. And then we have some builds of Chromium internally that provide an API, just like you can call performance.now, you can call performance.instructionCount and get the current number of instructions. And so this allows you, the profiler, to do a delta between times. And so I have a build of DevTools internally which uses this instruction count API instead of time. And we have more work to do. We have some folks working on it that aren't on the React team, but are on sort of our browser speed teams internally, that there's some more work to sort of do to remove noise. I mean, a big problem when you're profiling is you want to sort of make repeated runs as similar as possible, and that's really hard to do. So sort of removing a bunch of noise and getting these figures more reliable. But the idea is sort of twofold. One, once we've done this, we think that we can have, with a pretty high confidence, automated tests that run and use the React profiler to point out regressions in either React itself or in application code when it's changed. We could be like, oh, the number of instructions jumped up by 20%. This is a pretty solid signal that you've got a regression, and maybe that's fine. Maybe you added a huge new section of UI, maybe you didn't. A neat thing in the context of the React profiler, though, is that this would allow us, assuming we are able to land this in Chrome Public, which is the plan eventually, but this would allow us to use this API instead. So right now the profiler uses performance.now, or it falls back to date.now. So we could have it use this new profiling API if it was available. And then we could say, all right, given the fact that an average cost of an instruction is such, then here's the profile that you just recorded for a low-end phone, or here's what it is for a high-end laptop or a medium laptop, and actually sort of change those instruction counts to actual seconds, millisecond values, at which point we could definitely say, like, this part of the application is bad, you need to fix it. Or this part is good, and we have a high confidence that it's good, even on low-end hardware, because we know the number of instructions that it calls. So this is something like next year we'll probably be talking more about, but I'm really excited about it because that would allow us to do a lot more in the profiler than just say sort of, here's a bunch of information, like make sense of it yourself, like based on what we showed you.
Yeah, that's very interesting. And do you think that you would even be able to make that relative so that it would be useful even during development mode? So you could say, well, because you're in development mode, we expect it to have more instructions or something.
Yeah, it's hard to say exactly because dev mode is still going to be generating a lot more instructions already from things it's doing. So we do. The short answer is that we probably would still want you to use the profiling bundle. There's some parts of dev mode where we're doing, for instance, like where we call your functions twice to sort of tease out side effects. Sometimes we're able to sort of call the second time or the first time outside of our profiling scope. But there are some places where we sort of start and stop profiling where inside of that range, there will be some redundant calls. So dev mode's probably still not going to be great to use for anything other than sort of spotting unexpected cascading updates or unexpected like problems with memoization, things like that. But if you want to focus on time, you still would want to use the profiling bundle.
Yeah. Okay, cool. So just as we're wrapping up here, I think the recommended, I want to say my recommended approach for people who want to or identify performance bottlenecks, and I'd love to hear what your opinion on it. So what I tell people is don't look at the times, or don't benchmark or anything in development mode. Build it in production mode. If it's better if you actually do the profiling in production with like exactly how your user would do it, and for that to work, you have to have the profiler enabled. So that you can actually pull up the profiler. And then in addition to that, if you can get your hands on a device that's like the lowest common denominator device of your users and do the profiling there, then that is like the perfect. So get that bad device that your users are using and hit it on production and profile it there with the profiler DevTools enabled. And if you can't do that, you can sort of simulate it with the DevTools, but always make sure you're throttling so you can see what the real experience is like. Like, do you have any other additional ideas around that?
Yeah, I mean, those all sound like good advice. You can also, depending on what your budget is and what your hardware is, testing it on different networks can be useful. So maybe don't test it on your intranet and at your corporation, because probably your connection to your APIs are going to be fast, but maybe your office has like a external cable modem you can wire up to, or you can go sit in a Starbucks somewhere post-COVID and try it out. Yeah. That's definitely an important consideration. Test it in different browsers. That's another consideration there, especially if you're getting into the nitty-gritty of sort of fine-tuning optimizations. There's still a couple different browser engines left, so you want to consider them all because they each optimize things differently. Yeah, but that's good general advice.
Cool. One other thing that I wanted to ask you about is how Facebook does performance monitoring, because I know that you use the profiler, but I've pulled up the DevTools and I know that I don't think that I've ever gotten the bundle that has the profiler enabled. And so I asked you about this once and you mentioned how that works at Facebook.
Yeah, so that's a good thing. I should have mentioned that earlier. It's true that you can only use the profiling APIs in the profiling bundle, and that bundle is much faster than Dev, but it is still strictly slower than the production bundle because we're doing some additional things. We're doing very minimal additional things, but we are calling performance.now and storing some values and doing some addition and some minor things. So if you're not using that information, it's not a good idea to have your end users paying that cost for nothing. So what we do at Facebook is we have a framework from which we can run experiments on the server. And then the different JavaScript bundles we serve down to someone coming to Facebook will depend on the experiments they're in. And this lets us do all sorts of cool things in terms of A/B tests and things like that. But it also lets us pick at random a small percentage of our users, which is still a big bucket of users, that get the profiling version of React. And for those users, we'll log the times it takes to render certain parts of the page. So basically like 99% of users or something will get the faster production bundle, and then some small percentage of users will get the profiling bundle. And from that information, we can still see sort of regressions over time or improvements over time with the durations and stuff.
Yeah. Do you have like an internal tool for graphing out this time series data, or do you?
Yeah, lots of tools for that.
Yeah, very cool. And oh shoot, there was another last. Oh yeah, so the React profile is it? I can't ever remember if it's profiler or profile component, but that component, where do you typically see people getting value out of, like, as far as positioning? Like where do you typically put those? Like, of course, you're not going to have just one, like only one for the whole app, right? You want it to be scoped somewhere, and maybe actually you can speak to why you might want to scope it.
Yeah, I don't know if there's a definite like recipe for where you should put it, but I will say that like one place you could put it would be if you're using a router, maybe you want to wrap your pages. If you have an app that has a chat pop-up window or something, maybe you'd wrap that small part of the app. The thing that you would want to use to make this decision is the fact that, so there's two profilers. There's the DevTools extension profiler in your browser, which you run on your app, but only your app. And that profiler gives you fine-grained information about every component in your React app. And then there's the profiling API, like React.profiler, that you put into your source code that gives you summary information for everything beneath it. So if you were to use only one profiler in your whole app and put it around the top of the application, that would tell you every time the DOM was mutated and how long it took to render and how long it took to do the mutation. But if you saw a regression at a certain point in time and you thought, oh, I wonder what got slower, something in your app is all that we can tell you.
Yeah.
So
yeah.
When you're hunting down this sort of stuff, it might be good as a sanity check to put one at the root of your app, just to check for an overall regression. It might be slightly better to put one sort of in your application routing code, sort of around each route view. And this way you can see like, oh, the profile page had a regression, but everything else is probably fine. It is probably it is a bad idea to wrap every single component in a profiler, even though that will give you the most information. So the sweet spot is somewhere in between. It's probably closer to the side that's putting something around each route. And then maybe if you have like something special in your page, like a chat or an interactive map component or whatever it is, then you could also consider wrapping that too, to give you a little more sort of fine-grained signal. But we sort of leave that up to folks to decide based on the characteristics of their app.
Yeah, that makes a lot of sense. One thing that I show in Epic React is we wrap the whole app, but we only report on the mount phase. So like we just ignore updates and just say, this is how long it took for the user to see anything for your app. And I feel like that's a pretty good, I don't think that it would be a good idea to just wrap the whole app and report on every single one of those. That seems, I like the suggestion that you made. That was good. Well, great. We've been chatting for a while. Is there anything else that we didn't talk about that you want to bring up before we wrap up?
Yeah, I'll say that we're working on a new profiler that right now is a standalone app that has been deployed to Vercel. And if I could give the 1 minute pitch of this app, it would be that just like there were some gaps I mentioned in the built-in profiling tools, there's still some gaps when you're digging in the React profiling tool. If you say like, oh, this page took a long time this transition took a long time to render. Let's look at the profiler. And then we see, oh, like there's nothing particularly slow in here. I wonder why it took so long. And so like you sort of are missing the context in between. So we're working on a new profiler called, we're calling it the scheduling profiler. It will eventually be integrated inside of the DevTools extension, but right now it's a standalone app. And the way you use it is you record in Chrome's performance tab. You just use the built-in performance tab to record, assuming you're running a dev or profiling bundle. And then you do some things, and then when you're done, you stop and you export that JSON, and then you import it into this standalone app. And what it does is it renders a flame graph over time that looks very similar to the built-in browser's performance profile, except above that flame graph are going to be some boxes and dots that show when work was scheduled with React, when state updates were done, when components suspended, and then the flame graph for React components that were rendering, and when React committed and stuff. So and it shows all of this by priority, these like threads that we were talking about earlier. Mm-hmm. So this is cool because using this, you can see, for instance, like, oh, this commit took a long time because a bunch of things suspended and I had to restart, or because something suspended and there was a gap. Maybe I was working on idle stuff, but there was a gap while I was just blocked by IO and the browser did nothing. Or this took a long time because there was a huge chunk of JavaScript that was slow, that was outside of React. Like maybe I have an event handler somewhere that's totally unrelated to React. And so this gives you a much nicer sort of high level view. This thing doesn't show you props or state. So like there's some missing context in this too. So that's why I think it will eventually be nice to have it integrated and paired with the other one more. But I think this is a really exciting tool. We've already been using it a little bit inside of Facebook to find some sort of cascading update type bugs that it's nice because it shows you, it lets you drill in on exactly what happens. So if anyone's interested in seeing this, I've been posting some videos and pictures of it on my Twitter handle. Also some links you can play with the actual live profiler. I think I posted a link to a sample JSON profile and the profiler itself, so you can play with it. But this is one of the things I'm really excited about that we've technically already released an early version of it, but hopefully we'll do a release of the DevTools extension within the next couple of months that has it integrated more properly. So at that time, you wouldn't need to start and stop the performance browser stuff itself. React DevTools could do that. So right now it's a little manual, but it's a super valuable source of information, I think, too.
Yeah, that's very cool. I had no idea. I guess I missed your tweets about it. So I'm glad that you brought that up. That's awesome. There's another thing that I wanted to ask your opinion on, and that is how fast is React? Should everybody have to optimize every component in their application, or is it more surgical than that?
So like a trick question at the end. I mean, React is pretty fast. I will say that React is probably not, it's not been optimized and created with low-end devices in mind. So truly low-end, like integrated applications and things like that. There are some libraries like Preact or something that would be probably better choices that have a similar API if you're targeting really low-end.
Is that mostly for like memory consumption, like just the size of the library?
Can be both. Can be memory and can also be, it's probably mostly memory. Yeah. But that being said, React has a lot of optimizations built in. So we do, stepping away from React itself, like generally sort of industry standard advice for this sort of thing is avoid prematurely optimizing stuff. So I personally don't get caught up on avoiding every unnecessary render, because sometimes you might do more work trying to memoize a thing than you do just letting it render once in a while. And if a component renders and the children that it returns are the same or even slightly different, there are a lot of scenarios in which a component can render where React will itself know to bail out because no DOM attributes changed or nothing was added or removed from the child list ultimately. So there's a lot of sort of redundant optimizations for that sort of thing built in. So it's a good idea probably to use the profiling tools. If you see something slow, then you definitely want to say, oh, well, can I make this faster? And can I avoid doing it entirely on an update? So can I make it faster? Because you have to do it at least once. So like your mount scenario earlier, where you want to check that, like if you can make it faster, you're going to make the sort of time to interactive better for your users, which is strictly a win.
Mm-hmm.
And if you can't make it faster, can you at least avoid doing it unnecessarily again? But I don't think there's a hard and fast rule for it.
Yeah, yeah, that's great, and that's validating. That's the approach that I suggest people like. Fix the slow render before you fix the re-render, and like maybe you can fix both, but like do that in order and make sure you measure before and after so that your optimizations didn't make it slower.
Yeah, I will maybe point out, this might be getting too into the weeds, but the Profiler API gives you 2 times. It gives you, you're probably like, shut up, don't talk about that. But it gives you actual duration and tree duration. And these times are slightly different, and they're explained in the documentation. So I'd suggest folks just go check them out. But basically the tree duration is the best guess estimate at what it would take to render the entire tree as it is right now if it was the first render. And the actual duration is how much time it actually took to render the whole tree or a part of the tree in this commit. So if you render like a list of 10 things and each takes, I don't know, 100 milliseconds, this is just like maybe you'd have a second worth of actual duration. And then if you re-render and only 2 of them render and the rest of them bail out, then your actual duration might be 200 milliseconds, but your tree duration would still be 10 or 1 second, whatever.
Sure.
So like these numbers let you tease apart if you're getting to the level where you're trying to think, well, what should I optimize? Am I trying to avoid re-rendering, or am I trying to make the initial mount faster? Those figures give you slightly different information that can help you sort of spot the depending on which thing you're looking to optimize. You can use those numbers to sort of decide where to drill in. And this is the profiling API and the profiling extension in DevTools both give you these separate figures. I'd say in most cases, people are probably just interested in the actual duration one. That's the one that's reported first. But you have that second bit of information in there if you're really diving into the weeds.
Yeah, that actually makes so much sense. So you have the actual duration. The other one's called base duration. Is that right?
Or... Yeah, tree-based duration.
Yeah. Okay. Cool.
yeah, base duration. Yeah.
That actually, I'm really glad that you mentioned that, because I still until now I wasn't sure I understood that. I knew that it helps you know whether there was opportunity to memoize stuff. Or like whether memoization might be able to help, but now it makes sense.
You can kind of infer that based on the delta between the two. If they're always the same, then you have no memoization, unless it's a mount. So there's a lot of things you can tease out, and I feel like to actually fully understand it, you probably would have to read the RFC, because it's kind of a little bit of a weird, it's an unusual type of number, the way that we do it, but it could be a useful source of information if you're
really in the weeds.
Yeah.
Cool. Well, this is a super interesting conversation, Brian. Thank you so much for giving me some of your time. I hope that people continue to enjoy the wonderful work you're doing on the DevTools. If there's something that's like people want to ask you, or if they want to just reach out to you and follow to keep up on the stuff you're working on, where should they go?
I'm on Twitter. I'm pretty active. So my Twitter handle is Brian, BRIAN _D _Vaughn, VAUGHN. Get a lot of React questions there. You're welcome to ask them. The only thing I ask people is don't send them as DMs, send them as tweets. That way other people can find them too. It scales better. If I get the same question a bunch, I can just link rather than having to copy paste. So that's good. GitHub is another obvious one. I mean, me and the core folks normally I check React issues on GitHub every day. I haven't checked it in a week or so because I've been moving, but normally it's something I load up every morning and again in the afternoon just to look for anything that's sort of in the APIs and of course, if you tag, bvaughn on GitHub, I get an email notification. So that's fine too.
Cool. Awesome. Hey, thanks so much. Really appreciate your time, and we'll see everybody later. Bye.